Hi everyone, my name is Sadashiv and this is VitalSync, electronic health record and clinical management platform. I chose from Sprint 13's RFP options because it forces the real enterprise patterns like role-based access and yeah, we have the role-based access, we have appointment scheduling logic, we also have medical history timelines, prescription state viewing, and real-time availability tracking. I'll tell you that how I will implement in the Wireframe. Hold on for that. So yeah, to tell about the tech stack. Uh, my track is full stack engineering, and for the front end we have Next.js, TypeScript, Tailwind, CSS, and Shad CN UI, and of course React on the front end. Again, on the back end we have Nest.js, TypeScript framework. I use this to implement the type ORM. So we will implement the security or enhance the security by implementing service layer, repository layer, controller layer, right? So that's why I use the type ORM for Nest.js. It is built on top of the Express framework. So for database, I chose Postgres, which will be hosted on Neon Tech, and and the front end and back end will be deployed on Render and Vercel. So yeah, let us quickly look at the core features that will show our MVP, that is minimum viable product. So the four features are role-based access control, where we will have authentication mapping, where the doctors and patients will be the two roles that will be given access for the portal or our system. Next feature, we have real-time doctor availability and scheduling. So this feature allows the patients and the doctors to set and view their availability so that the patients or doctor do not have to waste time. So in queues or for waiting longer. So they can immediately know the appointment schedule in a better way, and to streamline that process, this feature we will implement. And the third, we have immutable medical history timeline, which means we will have a patient's health record from the past, whatever diagnosis, whatever prescriptions were given, who was the doctor who handled their disease or issue. So that will help for further diagnosis to look at what had happened to the patient in past. So next, we have prescription state management. This will help the patients a lot, because we will kind of implement a reminder or notification system for the patient, where the patient will be reminded it's time for them to take the prescribed medicines in form of whatever dosage was being prescribed. And like we will help the patients to know that this particular medicine or dosage has to be taken this much, 2 times a day, thrice a day, something like that. Fifth feature is something that I am adding on my own. So we will have on-demand medical archiving. That means we will help the patient to have their data in form of PDF or CSV, the medical history timeline especially. They can download the record of their history and can help or use it for further analysis or diagnosis. So I already told you the architecture. So this is something detailed we have about the architecture. And we will have the bcrypt in the backend for the passwords, and we will have JWT for the authentication. Um, Next, we will have the database. We have Postgres, as I told you earlier. We will have type ORM, type object relational mapping, that will allow us to replicate the Hibernate or GPA paradigms, right? So we will also have the type ORM migrations. So next, I'll take you to the Figma screens. So this is, I designed 5 screens as of now. Let me take you through it one by one. So first, we have simple authentication login page, where we will allow the patient or doctor to log in, and they can know their role in the backend. The backend will decide who will have what. So this is how the authentication would look like. Next, we have two roles, patient and doctor. The first one is doctor's dashboard, where we have the complete dashboard that will help the doctor to know their appointments and to manage the doctor's availability. Let's say if the doctor will be not available for specific time, they can update, she can update that. They can have a look at pending prescriptions, like whatever the prescriptions were not given or pending for the patient, they can update it from here. They will also have a clinical feed, like what are the major events or updates happening around in the clinic. So yeah, this is how it would help the doctor to manage this all of the things from the dashboard at once. Next, we will have the patient dashboard. The patient dashboard is much more simpler than the doctor's. So the main focus would be to schedule and get the timely appointment for patients from the doctor. Right, the patients can schedule their appointment based on the doctor availability, and they will get a timed event that will say uh, if the doctor is available, the event or appointment will be scheduled, or else it will say postpone the event or postpone the appointment for the next availability. And the doctor patients will also have the prescription block, where they will kind of get a reminder that whatever prescriptions were given to or advised to take, they will be given a reminder once daily, morning, before bed daily. They will also have how much dosage, whether 2 tablets, 1 tablet, or whatever the prescription is given. So yeah, they also have the blood pressure, current height, and weight. This can be achieved by, let's say, integrating an IoT device, smartwatch, or something. So yeah, this is how the patient dashboard would look like. Next comes the medical history detail. This is a part of patient's dashboard, where the patient can access and view the medical history, where they will have all of the records from past, the diagnosis and everything, where the doctor details who dealt the diagnosis and what are the prescriptions were given. So yeah, all of that can be used to further diagnosis or any future case. So yeah, this is one of the implementation of our MVP or the core features. So yeah, the bonus feature would be here that they can download the PDF or CSV. Of course, they need to be aligned a little more better. I'll do that. Next, we will have the patient dashboard because the responsiveness was the major constraint or requirement in our sprint. So yeah, this is how the dashboard on the mobile for the patient or doctor would look like. Yeah, they will have the upcoming appointment. They can reschedule. They can look at the prescriptions given. They can see their blood pressure, daily activity steps, and all of that. So yeah, this was about the implementing UI UX screens. I have given the link in the README in below. So let us now look at the entity relationship diagram. So for this MVP, as of now, I have designed 5 tables: users, appointments, medical records, availability slots, prescriptions. So first is user, which is basic authentication based required table. So based on this, we will have role-based access for patient as well as doctor. So for appointments, these table would be used for both of the roles. So appointment will be linked to prescription, where appointment ID is unique here, and appointment ID is used instead of doctor ID or patient IDs, because if the doctor ID and patient ID gets duplicated, so the prescription might say the two same doctor IDs for different prescriptions. To avoid that, I have created or I've implemented the appointment ID, which will be medical records table, would be storing the patient ID, which doctor had been dealing with the patient's health or diagnosis. We will have the doctor ID, what was the diagnosis, report, result, or symptoms. All of this we will have. We will also have the availability slot for the doctor, and they can have the start and end time. Based on this, the appointment scheduling will be done, and we will have the appointment table where the doctor ID and the patient ID will be used to schedule the appointment. Right. So this is how the entity relationship diagram would look like, and I have built this using dbdiagram.io. Next, we will look at the system architecture, where we have 3 layers: client layer, backend layer, backend service layer, and data processing layer. Of course, in client layer, we will have the next layers: Tailwind CSS, ChatCN, React based, TypeScript in the front end, and backend we will have Nest.js API controller. We will have role based access guards. We will have data transfer objects. We will have the service layer, which will use the ORM type, object relational mapping type ORM to be specific. So yeah, the last layer we will have the data and persistence layer. So these many layers are implemented in the backend to enhance the security. So that's the reason we have so many layers. For that, we will use the Neon tech for our database, PostgreSQL, and we will have the repository layer after the service layer, which will fetch or communicate with the database. We will have type ORM migrations so that any database changes would be implemented sequence wise, or sequentially, to be specific. So yeah, this was it. This is the README I have done yet, and yeah, I'm excited to work on this. Thank you.